14.3 enlargements, similar shapes and ratio all combined together. Okay, no more drawing, no more pencil and paper. This is just raw calculation now. It says the large triangle is an enlargement of the small one, so that's the daddy, that's the baby. Right, what is the ratio of the bases of the triangles? Alright, so the ratio of the bases is going to be 5 to 10, simplifies down to 1 to 2. That should be like an equals, not a, is that alright? So, B, what is the scale factor of the enlargement? I've gone from 5 to 10. What did I do? I multiplied by 2. Besides, the ratio says so. So, scale factor 2. Right, C. Find the missing height of the enlarged triangle. That's the question mark there. Well, very simple. 8 times 2, 16 centimetres. Alright, show my calculation there. 8 centimetres, double up times 2, scale factor 2, 16 centimetres. Peasy. Next one. Question 3, still page 219 here. It says triangle DEF is an enlargement of this little one ABC, so that's the big one there. Work out the ratio of the length of AB to the length of DE. Right, so let's just do that now. The ratio of AB, so let's just write it fully. AB to DE is going to be 8 to 40. Simplify it down. 8 goes into 8 once, 8 goes into 40 5 times. Oh, and give your answer in the form of 1 to n. Well, there's the 1 and there's the n, and the n is obviously 5, so I've done that. They could have just said simplify the ratio. Now, if it wasn't a nice whole number integer ratio, then we'd still have to write it in the form of 1 to n by dividing the left side by... Anyway, I'm not even going to get into that. They could have asked a more complicated question, but I've done it. Find the length of EF. Very straightforward. Well, how do I get from there to there using the 5.4? Well, it's the scale factor is 5, therefore multiply by 5. So part B is going to be using the scale factor of 5. I'm going to say 5.4 multiplied by 5 is, ask your calculator, 5.4 times 5, doing 27. So 27 centimeters. Done. Next question. Right, question 4. In the following diagrams, decide if the larger shape is in fact an enlargement of the smaller one. In both parts, all corresponding angles are equal. Well, of course, if all corresponding angles are equal, that really helps. So, are they enlargement of each other? Don't know yet. Let's just take a look. Right. If this is an enlargement, then the 3 and the 21 are friends. Well, let's have a look. Do a quick sum here. 21 divided by 3 is 7. So far, I've got an enlargement scale factor 7. Let's do the same with the 4. 4 and 28. They're the corresponding sides. So 28 divided by 4 is in fact 7. I've scored 2 out of 2. Now let's just do a different one here and pick a different colour that stands out. I don't know, a greeny thing. Let's just do that one. Right, next one. The 5.5 should match with the 38.5 if they're enlargements. So if this works out to be 7, then it really is an enlargement. That is an enlargement of the baby one. Now grab my machine and I'll let you know what the answer is in just a mo. 38.5 divided by 5.5 equals, it's exactly 7. Yep. So let's just write a quick conclusion somewhere. Yes, the triangles are mathematically, and the word is similar. Now that means all the corresponding sides are in the same ratio. Times 7, times 7, and times 7. It works. Are mathematically similar. Therefore, the big one is an enlargement of the small one. I'm not going to write that out. I've said that they're mathematically similar, and that's better wording. Now we'll do the same with this one, shall we? Right. So the 1.5 links into the 4.5. Let's just do a quick sum here. 4.5 divided by 1.5, I can see that's an enlargement of 3. What about this one? Well, it's exactly the same. 1.5 and 4.5, enlargement of 3. Now changing colour, I can see that the 1 links with the 0.5. Let's have a look. What is 1 divided by 0.5? Oops, 0.5. Because I'm thinking my answer, that's why I wrote a 2 there. 0.5. I know that half goes into 1 twice, therefore they are not mathematically similar, and I think they're trying to be trapezium or something. Anyway, so not mathematically similar. Meaning that this shape here is not an enlargement of this shape here at all. Okay, they don't. All the corresponding sides have to match by the same ratio, and failing that, we're wrong. Now, what's happening in question 5? Question 5. These triangles are enlargements of each other. Work out the missing lengths. Okay, I've got 3 corresponding to the 36. I can see that the enlargement is times 12. So from there to there, I just multiply by 12. So how do I get from 4 to this one over here? Let's just change colour, make a bit of a mess. From there to there, I'm still going to times by 12. So here I go. 4 times 12 is going to be 48 centimetres. Done. Next one, let's just do a greedy one. How do I get from question mark to 60? Or rather, how do I get from 60 back down to that one? Well, if I'm multiplying by 12 to go from small to big, I divide by 12 to go from big to small. So here I go. 60 divided by 12 is 5 centimetres. Done. Question 6. These triangles are also enlargements of each other. What is the ratio of the corresponding sides? Okay, I've got the 3 and the 24. Let's just write it there. 3 to 24 is clearly 1 to 8. So that's the enlargement of times 8 compared to the baby one. Alright, so scale factor is 8. Find the missing lengths. Okay then, so I've got you and I've got you. If you're 3, you are also 24 as well, because I'm multiplying you by 8. Now what about this height? I won't draw any more arrows, we'll get a right mess. So if I take my 2.4 multiply by 8, I should get the bigger height. I'll do it here, shall I? So 2.4 times 8 equals, calculator please, 2.4 times 8, doing 19.2. Why not? 19.2 centimetre height. Now what about working backwards? I will use an arrow here because I've got space. I'm going to shrink it down by 8, therefore divide by 8. So here's my calculation. 28.8 divided by 8. Here's our answer. That's exactly 3.6. Lovely. 3.6 centimetre base for that triangle. Find any missing lengths. Job done. What about question 7? Yeah, I've chosen this one because it's a bit of an unusual animal. Here's a diagram of some step ladders. Okay, so there's all the steps there, and it's held together by a rope. It says there are 2 similar triangles in this diagram. Yeah, I can see that. Draw them out as 2 separate diagrams. Okay, this is designed to help us get the question right. So I've got a big triangle like that. That's these step ladders. That's meant to be like beautiful. So it goes 150 across the bottom, and these 2 lengths add up to make 3. What's 216? 32. So 320 centimetres. Got it? And look, I've got a baby one just there. Look. So it goes like that. And we know this is called rope. That's the length of the rope. And here, I'm told is 160 centimetres. Alright, so I've transferred the measurements onto the... So that's going to be A and B together. I've transferred the measurements onto the diagrams in order to help me do part C. What is the length of the rope? Well, question. My 320 links into the 160. They're the corresponding sides. So let's just work out the scale factor then. I'm going 320 divided by 160, and I can lose that. I can see the 16 goes into 32 twice. So basically, it's the scale factor is 2. Alright, so if it's times 2 going that way, because 160 times 2 makes 320, then to go backwards, to shrink it down to the rope size, I must divide my 150 by 2. So here's my calculation. The length of the rope is 150 centimetres divided by 2, answer 75 centimetres. And that is done. Let's just sign it off. Mr. C, blah de blah de blah. That will do, and I'll see you quite shortly in the assembly.